Hi, everyone. Welcome to the WatersWorks podcast. I'm John K. Waters, editor-in-chief of the Converge 360 group of 1105 Media. This is the audio version of my May 20th post, Chromium's Quiet AI Revolution, Google's web stack goes agent ready. It was written by me, I believe, carbon-based life form, and given voice by Abby, a chatbot provided by Wonder.
This episode is a report from the annual Google I/O Developer Conference, which kicked off today with a keynote address by CEO Sundar Pichai at the Shoreline Amphitheater in Mountain View, California. The event will continue through May 21st, featuring sessions on artificial intelligence, Android, web technologies, and more. You can watch the live stream of the keynote and other sessions on the official Google I/O website or on Google's YouTube channel. 10 announcements Google made signal a genuine transformation. Chrome is now embedding AI models directly in the browser, DevTools have gained AI superpowers, and the entire development stack is being reimagined for an AI-native future. If you're a developer, a tech enthusiast, or simply someone curious about how AI is reshaping our digital experiences, you won't want to miss this discussion. These changes will impact everything from how websites are built to how we interact with web applications in the coming years. What makes these developments especially fascinating is how deliberately Google is laying the groundwork for the next decade of web-native AI, not with flashy announcements, but with thoughtful infrastructure changes that create entirely new possibilities. Let's look at 10 fundamental updates that I believe signal something far more profound than simple feature improvements. These weren't just incremental changes, they represent a complete reimagining of what a web browser is and what it can do. The browser, specifically Chrome, is evolving from being merely a window to the web into what can only be described as an AI operating layer. The browser is transforming from a passive rendering engine into an active computational environment. It's no longer just displaying content from servers, it's becoming an intelligent agent that can understand context, make decisions, and generate responses right at the edge. This isn't just adding a few AI features to Chrome. This is fundamentally changing what a browser is and what developers can build with it. Let's dive deeper into one of the most revolutionary aspects of Google's quiet transformation. Chrome now includes on-device AI models, beginning with Gemini Nano. This is a fundamental shift in how we think about browsers and web applications. Previously, if you wanted AI capabilities in your web app, you'd need to make an API call to a remote server, wait for processing, and then display the results. That meant latency, privacy concerns, and dependencies on network connectivity. Now, Google has embedded AI directly into Chrome itself. What does this actually mean in practice? Chrome now offers a suite of powerful AI APIs that run locally on your device. We're talking about the Summarizer API, which can condense lengthy content, the Translator API for converting text between languages, the language detector for identifying what language content is in, writer and rewriter APIs for generating and modifying text, and perhaps most importantly, the new prompt API with multimodal support. These aren't prototype features or experimental toys. As of Chrome 138, several of these APIs are fully stable and production-ready. If you're using Chrome Canary, you already have access to the newer Proofreader API and the Multimodal Prompt API, which accepts both images and text as input and returns structured AI responses, all happening directly in your browser. The implications here are enormous. Think about what this means for developers building web applications. You can now build experiences that leverage sophisticated AI capabilities without requiring users to install anything beyond their browser. The computational heavy lifting happens right there on the user's device. Real-world implementations are already emerging. Adobe's Acrobat extension now leverages the Prompt API to automatically generate summaries of scanned PDFs and validate critical document content, all without sending your sensitive documents to a remote server. Your data stays local, processing happens on your device, and the experience is seamless. Deloitte has reimagined their employee onboarding platform using the Writer and Summarizer APIs. New hires can now get AI-generated summaries of complex company policies, personalized learning paths based on their role, and automated guidance through procedural documentation. This dramatically streamlines the onboarding process while keeping sensitive employee information local to the browser. The key difference here compared to previous approaches is that this isn't AI in the cloud being accessed through a browser. This is AI embedded directly in the runtime environment of the browser itself. The models live in Chrome, execute in Chrome, and deliver results in Chrome. This local execution model solves several critical issues that have plagued web-based AI applications. Latency drops dramatically when you're not making round trips to data centers. Privacy concerns diminish when sensitive data doesn't leave the device. And perhaps most importantly, applications become more resilient when they don't depend on constant network connectivity or remote services. For developers, this changes the fundamental architecture of AI-powered web applications. You can now design with the assumption that certain AI capabilities are available natively, just like you'd assume access to the DOM or local storage. The browser isn't just displaying your application, it's providing computational intelligence to enhance it. What's most fascinating is how this approach democratizes access to AI capabilities. Users don't need high-end hardware or specialized software to benefit from these technologies. If they have Chrome, they have access to sophisticated AI models right in their browser. This represents a new chapter in how we think about application development and distribution. The browser is no longer just a thin client rendering remote content. It's becoming an intelligent execution environment with native AI processing capabilities. Now, let's talk about something truly revolutionary in the web development ecosystem: Google's new integration between Prompt Stack and Firebase. This development takes the concept of browser-based AI even further, extending into a full-stack AI solution that bridges client and cloud seamlessly. Web developers have always lived in a world split between client and server, and now Google's AI infrastructure follows that same paradigm. The new integration between Firebase AI logic and the Gemini Developer API creates what I'd call a truly hybrid AI execution environment. This isn't just technical jargon, it's a fundamentally different approach to building AI-powered applications. Here's what makes this integration so powerful. You can now design applications that intelligently determine where AI processing should occur. Have a simple text completion task that doesn't require significant computational resources. Run it locally in the browser using Gemini Nano. Need to process a complex multimodal query that requires a more sophisticated model? The system can automatically escalate to server-side execution using the full Gemini capabilities through Firebase. This hybrid approach solves one of the biggest challenges in building AI-powered web experiences: balancing performance, privacy, and capability. Not every AI task needs to be sent to the cloud, but not every task can run efficiently on a user's device either. With this integration, developers don't have to make that trade-off up front in their architecture. They can build flexible systems that adapt based on context. Consider the real-world implications. A collaborative document editor could use local models for simple grammar checking and text suggestions, operations where speed and privacy are paramount. But when a user requests a more complex operation like rewrite this entire section in a more professional tone, the system could seamlessly transition to server-side processing, accessing more powerful models without disrupting the user experience. The Prompt API integration with Firebase is particularly significant. It means you can create responsive UIs that behave differently based on runtime context, available computing resources, network conditions, and even user permissions. This creates an AI rendering engine that spans the entire stack, from browser to backend, providing a consistent experience regardless of where execution happens. Think about that for applications that need to respect strict permission structures or data governance rules. You can now build systems that keep sensitive data processing local when appropriate, but leverage cloud capabilities when authorized. Healthcare applications, financial services tools, and enterprise platforms all benefit immensely from this flexible architecture. What's particularly impressive is that this integration is available today, not as a future roadmap item or technical preview. Developers can start building these hybrid AI experiences right now, leveraging the full spectrum of execution environments from client to cloud. This integration represents a fundamental evolution in how we architect AI-powered web applications. Rather than forcing developers to choose between client-side or server-side intelligence, Google is enabling a fluid continuum where AI processing dynamically shifts to the optimal location based on the specific needs of each interaction. The result is a more resilient, responsive, and intelligent web, one where AI capabilities are distributed across the stack rather than concentrated in remote data centers. This isn't just adding AI features to existing patterns, it's reconceptualizing how web applications are structured for an AI-first world. Let's shift our focus to another groundbreaking aspect of Google's browser transformation: Chrome DevTools' new AI capabilities. This isn't just adding a chatbot to an existing toolkit, it's a fundamental reimagining of how developers interact with their debugging environment. Chrome DevTools has now been supercharged with Gemini-powered assistants across multiple panels, transforming the development workflow in significant ways. These assistants aren't standalone features. They're deeply integrated into the existing panels that developers use every day, including styling, performance, and network monitoring. Let's start with the styling panel. We've all been there, battling a mysterious layout glitch where elements aren't appearing where they should, or responsive design breaks at certain viewports. Traditionally, this meant manually inspecting element hierarchies, toggling CS properties, and often resorting to trial and error. Now, you can simply ask the Gemini assistant to explain what's happening. For example, if you have a flexbox layout that's misbehaving, you can highlight the problematic elements and ask, "Why isn't this centered?" The assistant analyzes the full CSS hierarchy, identifies conflicting rules, inheritance issues, or specificity problems, and explains them in plain language. But it doesn't stop at explanation. It can suggest and even apply fixes directly to your code. This isn't just saving time, it's actively teaching developers better CSS practices through contextual, problem-specific guidance. The performance panel sees equally impressive enhancements. Performance debugging has traditionally required specialized knowledge to interpret flame charts, timelines, and metrics. The updated Insights sidebar now overlays Lighthouse guidance directly onto your trace timeline, but with a crucial difference from previous approaches. This new system combines synthetic testing data with core web vitals pulled from real users, giving developers a comprehensive view of performance that bridges laboratory testing and field data. When you're trying to diagnose why your first contentful paint is slow, you're not just seeing abstract recommendations. You're seeing how actual users experienced your site, with AI-powered analysis to identify patterns and root causes. For instance, if your site has inconsistent loading performance, the assistant might identify that certain user segments on slower networks experience significantly longer load times due to a particular resource. It can then recommend targeted optimizations that would have the greatest impact on real-world user experience, not just benchmark scores. The network panel similarly benefits from this AI integration. Analyzing complex request waterfall charts can be daunting, especially in applications with dozens or hundreds of network requests. The Gemini assistant can now analyze these patterns, identify bottlenecks, suggest request prioritization strategies, and even detect anomalies that might indicate deeper problems in your application's data fetching logic. What makes these DevTools enhancements particularly powerful is their contextual awareness. The assistants understand not just isolated code snippets or performance metrics, but how they relate to your specific application. They can recognize common patterns and anti-patterns in frameworks like React, Angular, or Vue, and provide framework-specific optimization advice. Perhaps most importantly, these tools democratize expertise. Advanced performance optimization and debugging techniques that once required years of specialized experience are now accessible to developers at all levels. Junior developers can learn directly from AI-powered guidance that's specific to their actual code, not generic tutorials. Senior developers can move faster by offloading routine analysis to AI assistants while focusing their expertise on more complex architectural decisions. This represents a fundamental shift in how we approach web development tooling, from passive instruments that display data for human interpretation to active collaborators that participate in the problem-solving process. Now, let's dive into what might be the most consequential yet easily overlooked change in this entire AI integration: Chrome's new native agent infrastructure. This is a major paradigm shift that deserves your attention. The Prompt API and its associated AI tools are now part of Chrome's native API surface. Let me emphasize what that means. These aren't third-party add-ons, polyfills, or hidden sandboxes that might break with the next update. This is browser-supported agent orchestration built directly into the platform. For developers who've been working with AI tools, you'll immediately recognize how significant this is. Previously, integrating AI capabilities into a web application meant relying on external services, JavaScript libraries, or custom solutions that often felt bolted on. You had to manage authentication, API endpoints, rate limits, and all the complexity that comes with external dependencies. Now, Chrome itself provides the infrastructure for AI agents to operate within the browser environment. The browser is no longer just a dumb rendering layer that displays content and executes JavaScript. It's becoming an intelligent agent host with built-in capabilities for understanding, generating, and transforming content. Think about what this means for your applications. When you invoke the Prompt API, you're not making a network call to some distant server. You're accessing a capability that's as native to the browser as DOM manipulation or local storage. Your AI features will be more responsive, more reliable, and more deeply integrated with the rest of your application. This native integration also has profound implications for privacy and connectivity scenarios. Since these models can run locally, users can benefit from AI features even when offline or in low bandwidth situations. Applications can make intelligent decisions about when to process data locally versus when to leverage more powerful cloud models. From an architectural perspective, this represents a fundamental evolution in how we conceptualize the browser. For decades, we've thought of browsers as primarily rendering engines with some scripting capabilities. Then they evolved into application runtimes with the rise of SPAs and PWAs. Now, Chrome is positioning itself as an agent environment, a platform where AI-powered entities can observe, reason, and act within the context of web applications. Consider how this changes our approach to user interfaces. Traditional UIs are static until acted upon. They wait for explicit user input before responding. Agent-infused UIs can be proactive, anticipating user needs, suggesting actions, or automatically adapting to user behavior and context. And now these capabilities have first-class support directly from the browser. For companies building AI-enhanced products, this native infrastructure dramatically lowers the barrier to entry. You no longer need to be an AI specialist to incorporate intelligent features into your web applications. The browser provides standardized APIs that abstract away much of the complexity, allowing you to focus on creating valuable experiences rather than wrestling with implementation details. This isn't just a technical change, it's a distribution strategy. Google is essentially turning Chrome into the world's most widely deployed AI platform, reaching billions of devices without requiring users to install anything new. If you're building AI-infused UIs, Chrome is now offering itself as your delivery mechanism of choice. Not all the AI updates from Google were explicitly about artificial intelligence. Some of the most exciting announcements were focused on new UI primitives that are clearly designed with agent-driven applications in mind. Let's talk about carousels first. If you've ever built a horizontal scrolling component, you know the pain that comes with it. Managing scroll buttons, handling pagination, ensuring proper overflow behavior, and making it all accessible. It's typically required hundreds of lines of JavaScript and complex event handlers. Now, Google has finally delivered what developers have been asking for: carousels built entirely in CSS. These new carousel components come with native scroll buttons, proper fragmentation, and smooth scrolling behavior, all without writing a single line of JavaScript. This is a game changer for performance and maintainability. Pinterest, for example, reported that they reduced their carousel footprint by a staggering 90% just by switching from JavaScript implementations to these new CSS-based solutions. But that's just the beginning. Google also introduced significant improvements to tooltips and hover cards through a combination of 3 powerful APIs. The new Interest Invoker API, along with Anchor Positioning and Popover APIs. Together, these create a declarative way to handle tooltip triggers and positioning logic that previously required complex JavaScript handlers. What does declarative mean in this context? It means you can define the behavior and relationships between UI elements directly in your markup and styling, rather than orchestrating everything through script. These tooltips and popovers can now understand their context, position themselves intelligently relative to their triggers, and respond appropriately to user interactions, all with minimal code. The pattern emerging here is quite fascinating. Google is systematically eliminating JavaScript requirements for common UI patterns that will be essential for agent-driven interfaces. When your application needs to dynamically present recommendations, contextual information, or generated content, these declarative components provide a perfect delivery mechanism. These improvements might seem purely aesthetic or performance-focused on the surface, but they represent something deeper. They're creating a foundation for UIs that can be easily manipulated by AI agents. When an AI needs to present information or guide user attention, it needs reliable, predictable UI components that don't require complex scripting to control. The result is smooth, accessible, and state-aware components with dramatically reduced code requirements. This translates to faster load times, cleaner fallbacks for older browsers, and interfaces that are more maintainable and adaptable to different contexts. This convergence of declarative UI primitives with agent logic isn't coincidental. As AI becomes more integrated into web experiences, the boundary between static interfaces and intelligent systems begins to blur. These new CSS features provide the scaffolding that makes it possible to build fluid, responsive experiences that can be dynamically shaped by both user input and AI guidance. For developers, this means you can focus more on the intelligence of your application rather than wrestling with the mechanics of basic UI patterns. The platform is evolving to handle the presentation layer more efficiently, freeing you to invest your energy in the logic and capabilities that make your application truly smart. One of the most persistent challenges for web developers has been figuring out which features are actually safe to use across browsers. We've all been there. You discover an exciting new CSS property or JavaScript API, implement it in your application, only to find it breaks spectacularly in certain browsers or devices. Google is addressing this pain point head-on with comprehensive baseline support, now fully embedded across the development toolchain. This integration brings browser compatibility checking directly into the tools developers use every day. VS Code now provides real-time feedback about whether the features you're implementing are supported in your target browser set. As you type, you'll get immediate visual indicators showing if that shiny new API you're trying to use is actually production-ready. The same capability extends into ESLint configurations and post-CSS pipelines. This means your linting process can automatically flag potentially problematic code during your build process, preventing compatibility issues from reaching production. For teams working on cross-browser applications, this is invaluable. No more guesswork about which features are ready for prime time. What makes this particularly powerful is that it's not just static information. The tooling is connected to real-time browser compatibility data. So as browsers release new versions and implement new features, your development environment stays current with what's actually available. Beyond the IDE integration, Google has launched something even more comprehensive, the Web Platform Dashboard. This dashboard provides a complete mapping of the baseline status for every web feature. It's essentially a living document of the web platform's capabilities. The dashboard organizes features by category and shows exactly which ones are universally supported, which are still in progress, and which are coming next. For project planning, this visibility is invaluable. You can make informed decisions about which technologies to adopt now and which to defer until browser support improves. What's particularly interesting about this approach is how it transforms web development from guesswork into spec-aware development. Rather than building and hoping for the best, developers can now work with a clear understanding of the platform's actual capabilities. This is especially crucial as the web platform evolves at an increasingly rapid pace. New APIs are being proposed, implemented, and standardized faster than ever before. Having tooling that keeps pace with these changes moves us beyond the era of Canius.com lookups for every feature toward a more integrated, awareness-driven development process. For teams building AI-enhanced applications, this spec awareness becomes even more critical. When you're leveraging cutting-edge browser capabilities like the Prompt API or on-device inference, knowing exactly where the boundaries lie helps you design graceful fallbacks and progressive enhancement strategies. Your AI features can adapt based on the capabilities of the user's actual environment, rather than making assumptions that might not hold true. When we zoom out and look at all these changes together, it becomes clear that Google isn't just adding AI features to the web. They're fundamentally repositioning the entire web platform as a native AI runtime environment. This shift represents perhaps the most significant evolution in browser technology since mobile responsiveness or the JavaScript framework revolution. What we're witnessing is the transformation of Chrome from a document renderer into an intelligent agent container. The browser is no longer just a viewer for content, it's becoming an execution environment specifically designed to host and coordinate AI capabilities at every layer of the stack. Consider how these pieces fit together. Client-side Gemini models running directly in the browser, hybrid logic in Firebase that can seamlessly transition between local and cloud inference, multimodal prompt routing that handles complex inputs, and new UI primitives designed with agent interactions in mind. These aren't isolated features. They form a cohesive vision for how AI-native applications will function on the web. And that's it for this episode of the WatersWorks podcast. Be sure to check out the blog on application development trends, as well as the other developer-focused reporting on one of the world's longest-running tech trade publications. Thank you, everyone, and have a great day.